how we sketch a Nyquist plot last lecture, right? Nyquist plot is also known as a polar plot. Okay, so we are now here on frequency domain analysis. Alright, chapter 5. Okay, we start off with explaining to you. If you have a certain input, a certain frequency, right? And if you inject this input into your transfer function, J omega, you get an output, which is also a sinusoid. The same frequency, but multiplied with the gain of the transfer function and the phase. Okay? So essentially, for us to be able to understand anything about the output, alright, we must first be able to characterize the transfer function in terms of this gain and phase. Okay, so we've gone through a few examples. Alright, simple examples like this. Okay, if you have GS equals to 1 over S, so GJ omega is 1 over J omega. Okay, and from here, I hope all of you can just tell me that the gain of this is 1 over omega. Okay, and the phase, alright, for phase is negative tangent inverse, imaginary over the real part. So you have negative tangent inverse of infinity. And I hope that all of you can tell me that this is minus 90. Why? Because from the diagram over here is a tangent x diagram. Tangent is only infinity, and x is 90. Alright? So negative tangent infinity is negative 90. Okay? And how do you plot that? Just substitute different values of omega. Alright, from 0 to infinity. So you can see that the gain of GJ omega goes from infinity to 0. Okay? With a base of minus and alright, so you must tell me that omega is 0, start at infinity, omega is infinity, and at 0. The base is minus 90. Okay? And then we take it one step further to say that if you have a simple pole, what happens if you have a simple pole? 1 over S plus 1. Okay, substitute S is J omega. Alright, I hope all of you can tell me that the gain of this is now 1 over square root 1 square plus omega squared. Okay, and the phase is negative tangent inverse the imaginary over the real. Alright? How do you draw the Nyquist plot? How do you end up with this plot? Substitute different values for omega. Okay? And then when you derive the gain and the phase, let's say it's 1 and it's 0 phase, mark here. Okay? You end up with infinity at 0 and minus 90, mark here. Alright? Omega is 10, mark it here. Omega is 1, mark it. Okay, so the more omegas that you plot, you see that it goes. Okay, and last but not the least, give us the arrow, the direction. Okay, the direction. Alright, and then we took it another step further to say that if you have two poles, okay, a simple integrator and a single pole. Alright, so last week we stopped here. Okay? And the message is that, there are many ways to write the gain. Okay, what you can do is some of you may want to multiply out. You get minus omega squared plus J omega. Okay, and from here work out the gain, which is this. Okay, but it doesn't take you too long to say that, I can pick out omega squared. It is omega squared root omega squared plus 1. Or you can just tell me that I know that this is this. Okay? Gain of J omega is omega. Gain of J omega plus 1 is square root omega squared plus 1. Okay? And what's the phase? The phase you can just derive from the individual pole. For the integrator is negative tangent inverse, becomes 0. For the simple pole, negative tangent inverse omega over 1. Alright? What happens if we go one step further? Okay, if you have a 0 and 2 poles. In terms of the phase, the 0 will contribute positive phase. Okay, so this positive tangent inverse omega over 2. Minus tangent inverse omega over 0, minus tangent inverse omega over 1. What about the gain? Gain, you can tell me the gain is this. Alright, square root omega square plus 2 square over omega square over 1 plus 1. Okay? And very often we want to do some kind of scaling. Alright, so how do we do any kind of scaling? We will hope that this term stays 1, so it makes the analysis very easy. So you can scale this, so this becomes j omega over 2 plus 1. Okay? Over j omega and then j omega plus 1. Alright, so you can do this. Okay? And you should derive the same answer. First, if you were to take out the 2 from here, basically you end up square root omega over 2 square plus 1. Okay? Right? So you can go from here to here, or you go from here. Alright, so I think most of you have understood how to derive gain and phase now. Okay, so let's just move on. If you have a double integrator, which is also covered in the lecture notes, are you trying to copy? Okay, all I'm saying is that there are more than one way to get the solution. Okay, and I'm telling you that the recommended way is to just do it straight away. Okay, without multiplying by any complex conjugates. Okay? The better way will be to scale it so that this coefficient is always 1. Alright, and then it's easier when you do the calculation this way. Okay? Any question? Alright, deriving the gain and phase is a prerequisite. You don't do any exam question about prerequisites. Okay, so if you had derived the gain and phase from V, okay, you're definitely not there. And depending on how kind your lecturer is, you know, you may or may not get the rest. Okay, so let's hope that all of you right now are aware of how to derive the gain. Okay, so let's move on. If you have a double integrator, which is in your lecture notes, there's no need to copy. In straight away, and tell us that S equals to j omega minus 1 over omega squared. Okay, and gain is just 1 over omega squared. Okay, phase, we have two integrators. So minus tangent inverse infinity minus tangent inverse infinity. Minus 90 minus 90 is minus 100. Okay, this is already in the lecture. Alright, we also have the form in the lecture. How do you do this? Just substitute omega from 0 to infinity. Okay? Okay, and you know that the plot will tend towards minus 180 degrees. Or it will stay at minus 180 degrees actually. So what is minus 180 degrees? Is the negative variances, right? Okay, so we substitute omega equals to 0. We have infinity. We substitute omega equals to infinity. Yes. Alright, so the draw the matrix plot is just a straight line over here. And then drawing the arrow. Okay, why this line? Because this line is minus 180 degrees. Okay, so your matrix plot is this line. These already in the notes. Alright. So in the lecture notes we also have an example of triple integrator. Okay. Likewise, triple integrator subscript S is Q omega. Okay, you write again as 1 over omega Q. 3 integrators, so you have minus 90, minus 90, minus 90. Then there's minus 270. Alright, what's minus 270? It's this part of the axis. Because from here to here is minus 270. Okay, so if we substitute given values for omega, it starts from here, infinity, and move towards the 0 point. So this is your plot. So let's take things one step further. What do we expect from you if you are asked to draw an plot in the exam? Okay, to make things easier for you. Okay, so you know exactly what to write and mark it easier. Okay, so take for instance an example like this. GS is 1 over 1 plus S. The triple integrator and the double integrator are already in the just try to understand it. Okay? You can copy this or you can take a picture if you want to. Alright? So this is what we expect from you. Substitute S is Q omega. Okay? Easy. Next, we draw a table with 3 columns. Okay? First column, frequency. The second column, the magnitude of the Q omega. The third column, angle of the Alright, next, frequency omega, magnitude. From here to here, I hope all of you can tell me that this is 1 over square root 1 plus omega square. Okay, real square plus real square plus imaginary square. Real square root. Base, now you can do inverse the imaginary over the real. Okay, next, there are 2 rows that you certainly must have, which is omega is 0 and omega goes to infinity. Anything in between is up to you. Okay, to determine the kind of resolution you need for the next one. Alright, so substitute omega is 0, 1 over square root 1 plus 0 is 1. Negative tangent inverse 0, 0. Omega is 1, 1 over root 2, so as almost 7. Okay, tangent inverse 1 is minus 45. At this point in time, I need to tell you that don't be surprised. Okay, go home and check that you really know how to use a calculator. Because I have cases that people tell me, instead of minus 45, they say this is minus 1.2 or minus 0.4. But they are calculating readings, not numbers. Okay, so we need this in degrees. Alright? You can tell me omega's 2, 5, 10, up to you. As long as it's sufficient to draw a nice plot. I would think the best at least 5 points, at least. Okay, so you can go to 8 points up to you. So how do you plot a nice plot? Okay, with those values. Okay, so here are the star protractor required. What you're supposed to do is omega 0 is omega 1, omega 0 is 0. Just mark. Make it a 0.707 minus 45. What do you do? Put your protractor on the graph. Okay, you'll be expected to draw on graph paper. Alright? Measure 45 degrees. Okay? Put your mark with the dot. Alright? Then using a ruler. Okay, in the question we often tell you that use a scale of 1 unit to 2 cm. Okay? So if that's the case, tell us how many cm. Okay? So if 1 unit is 2 cm, this is 1.414, and this is 0.9 cm. Okay? So with your ruler, place it from your origin to the dot, then you just mark out 9.5, measure 1.414, and then mark it across. Alright, move on. Minus 63.4, put your protractor back on, find out where is minus 62.4 degrees, mark it with the dot, put your ruler back here, okay, measure 0.9 cm across. Okay, then join the points and draw me the direction of movement. This is just a sketch, but in the exam you're expected to draw a problem. Okay? Alright, we have covered most of the examples in the lecture notes. Okay, can I suggest that we break for 5 minutes? So if any of you, the reason why I'm breaking for 5 minutes is if any of you cannot get the gain and the phase, you do not understand how the gain and phase is derived, come down. After this break, after this 5 minutes break, okay, you will be expected plot on live spot. Alright, for pass the exam question. So I'm going to flash the exam question and then you plot. Alright, okay?